Today we will be taking one question from projectile, okay, where it's given that a particle thrown over a triangle from one end of a horizontal base. Okay, so let's say this is the xy plane, right? If this is the xy plane, this is x, this is y, right? And let's say the projectile is thrown over here like this with a velocity u. Now it's given that the particle thrown over a triangle. So this projectile is formed, but basically this is thrown over a triangle. So let's say if this is a triangle, triangle A, B, and C, right? So this particle is thrown over this triangle. Okay, this is the triangle which is formed, right? And it just falls on the other end of the base after grazing the vertex. So this projectile is formed like this, that from here it start bending, right? And here it touches the base, touches the vertex, and grazes here and just falls over here on the base on the other end. This is the other end and this is the starting end, right? So this is the movement of the projectile which you can see, right? This is the movement of the projectile. Now from here it's given that if theta and phi are the base angles, right? So here let's say if this angle is theta and this angle is phi, because these are the base angles. AB is the base of this triangle ABC and theta and phi are the base angles, right? Then we need to prove that here is also given that alpha is the angle of projection. So this angle is alpha, right? So alpha is the angle of projection. So this projectile is thrown at an angle of alpha, right? Hi Gohan. So here we need to prove that tan alpha equal to tan theta plus tan phi. That is tan alpha is equal to tan theta plus tan phi. This we need to prove, right? So let us start it. Okay, I didn't getting you Gohan, right? So here basically you can see this is the maximum height which is attained by the projectile, right? This is the maximum height h. So when u is the initial velocity of the projectile, there are the two components u sine alpha here. If u is projected, the projection velocity is u like this at an angle alpha. This is alpha. Then the vertical component will be how much? It will be u sine alpha, and the horizontal component which is responsible for the horizontal displacement will be the horizontal component of the velocity, that is u cos alpha, right? I think this two part is clear to you, right? Now coming to the explanation. Okay, so if we are saying the u be the initial velocity of the projectile, right, and this c is the vertex, right, let t be the time taken from when the projectile is fired from A and reaches C, that is to reach the maximum height. Let t be the time period. T is equal to time period, right? Now do one thing. Considering the vertical motion, what we can do, if the vertical displacement, that is h, the vertical displacement is h, right? Then s equal to ut minus half at square, right? So using that, the vertical component of the velocity, that is u sine alpha, this one, as you can see over here, into t ut minus half gt square, half gt square, right? This is the value, this is the value of the vertical displacement, right? That is h. So, and this a, let's say this is the point D, right? Now AD is the horizontal distance traveled in this time of t seconds, right? Because t is the time period when it reaches from A to C, right? So the horizontal distance covered is AD. In that case, the horizontal distance, this one, AD, can be written as horizontal component of the velocity, that is u cos alpha, right, multiplied with the same time t, right? Now here you can see theta. If you form a triangle CAD, in this triangle, you can see what is the value of tan theta. So tan theta can be written as this height h divided by d, that is AD. So h by AD is the value of tan theta perpendicular by base. So putting up the value h as it is, and in place of AD we calculated u cos alpha into t, u cos alpha into t, and basically, let me zoom a little, yeah. So here h is also known to you, that is u sin alpha t minus half gt square value, right? So putting up the value of h, we get tan theta is equal to u sin alpha t, this one, minus half gt square divided by, let me zoom a little, I think it's better now, fine. Now minus half gt square divided by u cos alpha into t, right? This will give you, when you divide u sin alpha t by u cos alpha, u will be cancelled out, and sin alpha by cos alpha will be tan alpha, right? So this will give you, and this t also cancelled out, so this will give you tan alpha, right, minus t cancelled out because 2t over here into the numerator, so this will give you g into t divided by these two, right? Then u cos alpha. So we get the value of tan theta from here, right? So tan theta is tan alpha minus gt by 2u cos alpha. So this is the relation which we have derived, right? Hi Christopher, hello. So from here tan theta equal to tan alpha minus gt by 2u cos alpha, right? Now what we can do, similarly we can see the total horizontal range is AB, right? So if the horizontal range is AB, the horizontal range, if we say, it is A to B, because from here the projectile is fired and reaches till this point, right? Now, here as per the question, this point is just matching with this, so this is considered as a single point. This projectile is falling like this, right? Falling like this, actually just it matches the base of the triangle. Okay, so don't go with the figures, there is little mismatch over here. This point coincides. When the projectile falls, it just falls around the base, just approx at the base B. So here the horizontal range AB can be given as, if you remember the formula, u square sine 2 theta by g, u square sine 2 theta by g, but in place of theta it's basically this angle, which is alpha. This is alpha, right? So u square sine 2 alpha by g, right? So this will give you u square sine 2 alpha can be written as 2 sine alpha cos alpha, right? So this will give you the length of AB, but we will expand it later, or we can write US square sine 2 alpha can be written as 2 sine alpha cos alpha divided by G. So this is the length of AB. Why we are calculating AB? Just to find the length of DB, this one. What is DB? Once DB is calculated, we will take the tan phi, what we need to prove, right? Tan phi will be CD by BD, but we are knowing the length of CD, that is H, and H is u sin alpha into T minus half GT square. Putting upon the formula, S equal to UT minus half AT square, S to UT plus half AT square, right? And here A is minus G. So anyway, now when AB is known to you, then you can calculate BD, right? This BD, this length. So BD can be written as AB minus CD. Tell me, can we write it like this or not? AB minus AD. This is AD, and AD is calculated to you. That is u cos alpha into T, right? AD is calculated to you. Now, what we can do, if BD is known to you, then we can say tan phi is CD by BD. Tan phi is CD by BD, right? Because this is CD and this is BD. So tan phi can be written as CD by BD. Now, what is CD? What is CD? CD is H. This is CD. This is basically CD, right? So here we can write tan phi can be written as CD, which is H, right? H by BD. So BD is basically AB minus AD. Let me write AB minus AD in place of CD, right? Because this is AB and this is AD. So from AB, when you remove AD, you are left with BD, right? Now, when you just put up the value of H from here, because this is the value of H, right? So from here you can take the value of H, and AB minus AD can be easily find, because AB is known to you, and AD is also known to you. AD is what? here you can see AD is u cos alpha into t. So this is also known to you. Just put up the values now. So tan phi is equal to h by AB minus AD. So which can be written as h can be written as sorry h can be written as, from here just put up the values, u sin alpha t minus half gt square, u sin alpha into t minus half gt square, right, divided by AB minus AD, right. AB is here 2u square sin alpha cos alpha by g. So just write up the value 2u square sin alpha cos alpha by g, right, because this is the value of what, AB here, this one. You just put up the values AB from here to here, minus AD. What is the value of AD? AD is u cos alpha into t. So just write minus u cos alpha into t, right. So this is the value of tan phi, right. This is the value of tan phi. When you simplify it, you get the value of tan phi. Let me write it what we have already derived, as already written. Tan phi is equal to u sin alpha into t minus half gt square, that was the height of the projectile, right, divided by 2u square sin alpha cos alpha, right, minus divided by g minus u cos alpha into t, right. Now this is the value of tan phi. Now let us simplify it, right. When you simplify it, you can see tan phi is equal to, when this is half gt squared, this 2 will be going into the numerator, so this will be 2u sin alpha t minus gt square divided by these two, right. Then we have here 2u square sin alpha cos alpha minus u cos alpha into g, u cos alpha into g into t, right, and this g will be going to the numerator now, because this is denominator's denominator, right. So that's why we have not written here into the denominator. Oh, no more maths. No, it's basically physics, dear Onyx. Yeah. So we need to show that how the statement, how the proof can be shown to you, right? So we could not escape up to that level. Yeah. So tan phi can be written as 2u sin alpha into t minus gt square and into z divided by 2 times 2u square sin alpha cos alpha minus u cos alpha into gt, right? So this is the value of tan phi now. Now, from here, when you just further simplify it, we get the value of tan phi tan phi as equal to, here you can see 2u sine alpha minus gt square. So one t can be taken out as common from here. So and this g can be written outside the bracket, g into t, and inside the bracket we have 2u sine alpha minus gt, right, into the numerator, and divided by into the denominator it will be 2, here you can see u cos alpha is here and u cos alpha is here. So that's why 2 is already there outside the bracket. So we have taken out 2u cos alpha and we are left with 2u sine alpha from the first term minus gt, right? So this will give you, see here you can see 2u sine alpha minus gt, 2u sine alpha minus gt. So this will be cancelled out, this entire term, right? And you are left with tan phi is equal to gt by 2u cos alpha, right? Since tan phi equal to gt by cos alpha, which tan phi equal to gt by 2u cos alpha, we have find it out, and we have already find the value of tan theta. The value of tan theta, let me write it out, it was tan alpha minus gt by 2u cos alpha, right? So you can see the similarity over here, because you can see we have already proved what is the value of tan theta from here. Tan theta equal to tan alpha minus gt by 2u cos alpha, right? So when you just add it, simply add it, okay? When you add the above equations, you just add it. During addition, you can see tan phi plus tan theta will be coming tan phi plus tan theta into the LHS will be equal to tan alpha, and here gt by 2u cos alpha and minus gt by 2u cos alpha, this will be cancelled out, right? So this was our requirement to prove tan phi plus tan theta is equal to tan alpha, and in this way we have proved this, right? tan phi, right, plus tan theta, right, which was our RHS, is equal to the LHS tan alpha, which can be further written as, you can write it vice versa also, tan alpha equal to tan theta plus tan phi. So in this way, students, we have proved it, and this was a good question, okay? So initially when you read the question was that a particle thrown over a triangle. So this was the triangle ABC, this was the triangle, right? So the particle is thrown from here like this, and it grazes over here and falls at the base of the triangle, the other side, right? So the question is that the particle thrown over a triangle from one end of a horizontal base, so this is the one end of the horizontal base, falls on the other end of the base. So this is the other end of the base B, right? Now after grazing the vertex, so the projectile is fired in such a way that it just crosses and after grazing the vertex. So this triangle ABC is there and C is the vertex of that, right? Now, from here, if theta and phi are the base angles, so this theta and this phi are the base angles of this triangle, right? Then, and alpha be the angle of projection. You can see this alpha, this is the angle of projection of this projectile. This is alpha, right? This is basically alpha, the angle of projection. So from here, we have proved that tan alpha equal to tan theta plus tan phi, which was our requirement. That is tan alpha equal to tan theta plus tan phi, right? So students, I hope you understand the solution, and thank you so much for watching. Keep on learning. Bye bye.